Hi guys. We are going to start chapter 16 today, but because of time, we're going to go to section D, and we're going to talk about the chi-squared goodness of fit test, and then we will also get through the chi-squared test for independence. So kind of just introducing the chi-squared goodness of fit test. You will want to have your graphing calculator with you as you listen to this video today so that you can follow along. I do not have a TI-83 at my house, and so out on my website you will see that there is a link for calculator instructions, and on that link there is a video to help those of you that have an 83 at home to know what buttons to push to be able to do the chi-squared goodness of fit test. Because of time, we are not going to do this by hand. We're only going to use the calculator. So, what is the chi-squared goodness of fit test? Well, it's a test that we can use to hypothesize our population proportions, and you use it to see if your sample data, whatever that sample data is, fits a certain distribution, whether it's a normal distribution or something other than normal. And it's designed for that certain population, whatever you are, whatever your population may be. The population proportion is a parameter that describes that percentage that is associated with that population. And it is usually going to happen when the frequency of your population is very different. So if you think all the way back to when we were using frequency tables with one variable, that is when you would use chi-squared goodness of fit test to see if it truly does fit a certain distribution. So what is the purpose? Well, in simple terms, it's going to tell you if that sample data, whatever you have of your data, is representing the data that you would expect to find in the actual population. So the important word there is going to be expect. And if we think about our probabilities, the probability of something that we expect to happen is theoretical probability. So for example, the probability of us expecting to get a heads when we flip a coin is 1/2, because we know based on our knowledge of a coin, one out of the two sides of the coin is a head. So we will talk about theoretical probability within our goodness of fit test. So when do we use it? Well, we are going to use it when we have one categorical variable. That's the important piece. You only have one, and it's a category. So rolling a die, your categories are the numbers 1, 2, 3, 4, 5. Or if it's a survey, your categories could be highly satisfied, satisfied, neutral, dissatisfied, or highly dissatisfied. Those are all categories, and that is a one variable situation. So we use the goodness of fit test when you have one categorical variable for a single population. So let's look at an example here. Rika rolls a die 60 different times and obtains the rolls in this table here. So he got a 1 20 times, a 2 10, etc. And those relative frequencies are the proportions of the outcomes. And if you look at that frequency, those are fairly different. He got 1 20 times, but then only got a 3 5 times. So he's going to use the chi-squared goodness of fit test to determine if his dice is, or die I should say, is biased. We want to know if this hypothesis is in fact true. Is it biased? So some terms that we need to know in order to figure this out. So your null hypothesis is denoted by H sub 0, and that's what you're going to hypothesize. The H sub 1 is your alternate hypothesis, which is denoted by H sub 1, and it's basically just the not of your hypothesis. So if I hypothesize that my method, for example, is effective, then my alternate hypothesis would be that it is not effective. Your significance level is denoted by our symbol of sigma, alpha, and it is a percentage that is given to you. So the significance level that is given is either going to be 1%, 5%, or 10%. Those are the only options that you will have to know. The p-value we are going to use our calculator to find, and we actually use that p-value and compare it to the significance level to determine if we are going to reject the null hypothesis or not. Your degrees of freedom, that is going to be used to be able to find your p-value. So your degrees of freedom is going to be the number of categories that you have minus 1. And that degrees of freedom is going to help us find our p-value so that we can then compare that to our significance level, which again is given to us, and then that will be able to determine if we will reject our hypothesis, our null hypothesis, or not. Okay, so if we go back to Rico's example, our expected frequency is always going to be the number of trials we have times that theoretical probability. So he did 60 trials, and when we roll a dice, we have the numbers 1 through 6. So theoretically, we would say that we have 1/6 of a chance to get any of those numbers. And so 60 trials times 1/6 is 10. So we would expect to get 10 of each number if we're going to claim that the die is fair. And so let's go through our process. So to actually construct this test, what's happening, what your calculator is doing, we denote it. This is the chi-squared symbol. It's not an X, it actually is a Greek letter chi, so make sure that when you're typing it, it is not just an X. But chi-squared calc, that's our calculated statistic here, and that is found by the sum. Remember that E is the sum, which is our sigma, of your observed, the F sub OBS or F sub O is your observed frequency, so what you actually did in your experiment, minus the expected, and that quantity squared, and then it's all divided by your expected frequency. So this is the calculation that your calculator is doing. Now, if you have a TI-83, it's going to take a little bit more work for you to get this actual value. But if you have an 84, you actually have a goodness of fit test on your calculator. Okay, so let's go through and let's walk through how we're going to do this with our example of the rolling of the die. So our numbers, we have the numbers, and I'm just going to show it out a little bit by hand, but we're not going to fill this whole table out. So we have the numbers 1, 2, 3, 4, 5, and 6. So those are the numbers on the die. And then our observed, well, I got a 1 20 times, I got a 2 10 times, 5 times, 8, 7, and 10. And then the expected, remember our expected value, we took our 60 times that it happened times the 1/6. So we expect a 1 to happen 10 times. We expect a 2 to happen 10 times, etc., etc., etc. So in this case, they're all the same. They're not always going to be the same, but they will all be the same. Now those are the only columns I'm going to fill in because, again, like I said, we're only going to do this using the calculator versus using the, or doing it all by hand just because of time. So these are the two columns that are important for us. So now I want you guys to do this with me. So I want you to go to your calculator and the first thing we need to do is put those two columns into L1 and L2. So if we go to Stat and hit Edit, clear out your L1 and L2, and then in L1 is always going to be your observed, L2 will be your expected. So we will go 20, 10, 5, 8, 7, and 10, all in L1, and then L2, we have our tens. And we should have the same amount. Now, if you have an 83, I just for the sake of the timing on this video, I would like you to go out to my website and watch the video on how to use the 83 so that my video isn't ridiculously long. So with you 84s, the next thing that you're going to do is we need to determine our degrees of freedom. And so our degrees of freedom is going to be our number of categories, which are categories, there are 6 categories basically because there's 6 numbers, and we subtract 1. So our degrees of freedom is going to be 6 minus 1, which is 5. And we'll fill in this other stuff in a second. Okay, so on your calculator, you're going to go to Stat, and then you're going to scroll all the way over to Tests, and under Test, you're going to scroll down, and you're going to see, I'm just going to write it, let me scroll down a little bit. You're going to see chi-squared GOF test. That's what it's going to say, standing for goodness of fit. So you'll scroll all the way down, and I want to say it is D. So you got to scroll for a little bit. And you're going to hit enter once you're there. And your observed, it should say L1. Your expected should say L2. And then we just found our degrees of freedom was 5, so change that to 5. And then hit calculate. And we find our chi-squared calc is roughly 13.8. And our p-value we find is 0.0169. Okay? Now the CNTRB, that stands for the contribution. So basically all those numbers there are telling you how much each of your numbers are contributing to that chi-squared value. So you can see that the number 1, let's see, like the number 1 is contributing 10, the number 2 is contributing 0, 3 is contributing 2.5, 4 is contributing 0.4, 5 is contributing 0.9, and 6 is contributing 0. So as far as the values go to get that chi-squared goodness of fit, the number 1 is contributing the most to get that 13.8. Okay, so we have our chi-squared. So now we need to kind of think about our hypothesis. So let's scroll back up here and let's fill the rest of this in. So our H sub 0, our null hypothesis, would be that our die is fair. So the die is fair. So the opposite of that for our null hypothesis would be that the die, whoops, the die is biased. Okay, our significance level, I actually forgot to tell you what we were going to do. Let's go a significance level of 5%. So if we use 5%, our alpha is going to be 0.05. Okay, and in order for us to know if we want to accept or reject our H sub 0, the rule of thumb is that you're going to reject H sub 0 if your p-value is less than your alpha, which is your significance level. So if we look at our p we found was 0.0169, and we compare it to our 0.05. Well, this in fact is less than. So our p is less than, which means that we are going to reject H sub 0, and therefore we can conclude that the die is biased, which is what Rico originally was saying about it, and so his thought on the die was correct. Okay, so let's think about all of the stuff that we just did, because I just showed you a lot of things. Let's just walk through these steps. So technically, step 1, you're going to state your null hypothesis and your alternate hypothesis. So tell me what the h sub 0 and the h sub 1 is. And then you're going to identify the significance level, which again will be given to you. And then you're going to calculate that value of the test statistics. So this step 3 is us using that calculator, putting it into L1 and L2, and then going to that test and doing the chi-squared GOF test and identifying that degrees of freedom to then be able to calculate that. And really step 4 is also what's in our calculator. Like step 3 and 4, those parts are what you're doing to use your calculator. And then once you have done that, you have your p-value and your significance level, so you can compare those, and if p is less than your significant level, then you are going to reject h sub o. And if it's not, if your p-value is greater than it, then you do not reject it, and you accept that h sub o. And so then that last step is you're going to interpret it, and make sure when you're interpreting it that your conclusion is a sentence. So like we wrote on that last example here, on the very bottom, I just said reject h sub o. I didn't write a complete sentence, but that is that conclusion that must be there. So you have to make sure you're identifying what you're agreeing with. And that is